Okay, a reminder. My name is Ron Bannon. My email address is Bannon, that's B as in boy, the at symbol, NNON.US. All right? So we're on problem number 3. And again, I'm coming across this term that Wells used in his text, consecutive number. Nowadays, we wouldn't say that. We would say consecutive integer. And consecutive integers are the form, provided that x is an integer, the next integer would be x plus 1, and the next integer would be x plus 2. But again, in the conventions of language, when people say number, typically they mean integer. All right, what do they say? The 3 consecutive numbers such that the sum of their squares. Well, if you wrote that down, the sum of their squares would be x squared plus x plus 1 squared plus x plus 2 squared. And they say that equals 434. All right, I want to just go to the key now. And I want to say really what we're doing is we're trying to study. We're trying to study the material, all right? Now, if I go to the key, I do talk about this. The use of the word number in this context is indicative of the word integer. Then I said let x plus 1, x plus 2 be the 3 consecutive integers, and then I write the equation down. So I got to my first milestone. Let me erase this over here. So when you get to your first milestone, your next milestone is, can you answer the question, all right? So the way I would do that, and again, I know there's missing steps here. I'll put them down for you. You would get x squared plus x squared plus 2x plus 1 plus x squared plus 4x plus 4, and that equals 434. Well, 1, 2, 3x squared. Let's see. 2x, 4x is 6x. 1 and 4 is 5. But I'm going to take 434 from both sides, so minus 429 equals 0. And again, my claim is I'm getting to this step over here. All right, get my eraser out. Again, I'm working step by step. This is done. And now, of course, the factorization. Now, looking at it, I notice those 3 numbers are divisible by 3. So, and the reason that 429, the sum of the digits, 4 plus 2 is 6. 6 plus 9 is, of course, a number that is divisible by 3. It's 15. So I'm using rules of divisibility. And what do you get over here? 0. I'd factor a 3 out. And then you get x squared plus 2x. And then what do you get? Well, let's put it down. 3 into 4, 29. 1, 3, 12, 4, and that's 9. You get 3. 143. Get my eraser out. Not there yet. And I'm looking at 143. And, gee, that's a tough one, isn't it? 11 times 13. Let's put that down. 0 equals 3, x, and 11 and 13. The product of 11 and 13 is 143, and they do differ by 2, so it's going to be plus 13 minus 11. So the answer here is x equals 11, and the other answer is going to be x equals minus 13. Whoops. Again, if I chose 1, what would you get? You'd get 1. The next consecutive integer would be 2. The next consecutive integer would be 3. All right? So, oh, I'm sorry. I was going to say it doesn't make any sense at all. I'm sorry, 11. I don't know why I wrote 1 down. This would make no sense at all, by the way. I'm sorry, 11, 12, and 13. Again, what I would do is I check it. 11 squared plus 12 squared plus 13 squared. Let's write that down. 121 plus 144 plus 169. All right, I squared them. I add them together. 100, 200, 300. I'll write that down. And then 20 and 40, 60, 60 and 60 is 120. And then 1 and 4 is 5, plus 9 is 14. And what would that give you? 34. And that's what they said it was, all right? So that works out beautifully. Let me erase this over here. I want to put that in the other integers though. And what would that be? Minus 13. Well, the next one up from that would be minus 12. And next one up would be minus 11. And again, when you square those things, you're still getting 11 squared, 12 squared, and 13 squared. So this is also acceptable. However, let me read this to you. I do claim this. Incidentally, Wells does not list the negative solutions. And I presume this is because negative numbers were not grammatically considered to be numbers in this time. And again, his time goes back to 1904, right? And during that time, they weren't seeing numbers as being negative, right? Numbers, when they said number, they meant integer. Now, granted, I think probably that wasn't universally held belief, but that's when Wells was writing problems. That's how he'd answer it. So he'd only list 11, 12, and 13. That's all he'd list, all right? I would say even today, I don't think it would be polite to use a negative number when asked for a number, right? Like it would almost be like a joke if someone asked you, hey, think of a number, and you said, oh, minus 7. They would think that's kind of a peculiar answer, by the way. But anyway, I want to say this. Typically, when we're asked a number, the general and appropriate response should be what's called the natural number, all right? And that's pretty natural, all right? All right, thank you.